quick run through on notes for triangle similarity. And we're going to focus on relationships that are specific to triangles or things that look very triangular with the way they're shaped. Okay, so what we're going to try and do is review some of the stuff about congruent triangles, but then extend it into similar triangles. So on a congruent triangle, all corresponding sides must be equal, and all corresponding angles must also be equal. But on similar triangles, the sides just need to be proportional or proportionate. Both of those mean the same thing, and all the angles have to be equal. Okay, so on angle, 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 that means that all three angles are equal. That is not enough to say for congruent triangles, because we would also need the sides to be equal. On similar triangles, though, that's fine. That's actually a shortcut that gets us to having the same shape and possibly different sizes. One of the neat things about angle, 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 and angle, angle is that they're the same, because if you have two angles, the third one has to add up to 180. So it's kind of like it's locked in already. It can't be anything extra. For congruence, not enough. But for similarity, it is definitely good evidence. Side, side, side. Now, let's think about this for a moment. If it's equal, that's good evidence. I'm going to say it's good here, but only if all sides are same proportion. What do we mean by that? We'll see that in some of the examples as we go down. For now, you can just make sure you're marking the right things. Side, side. That's not enough info for congruent, and it's not enough info for similarity. Angle, side, angle. That's actually good enough for us for congruence. And what's interesting is because we already have 1, 2 angles, then that's fine for similarity, because we have the 2 angles. The side is just extra. And if the side was proportionate, awesome. If it was equal, awesome. It still fits into the umbrella of similar. Because for something to be congruent, that means it's still the same shape. So congruent means same size and same shape. Similar means same shape, possibly a different size. But same size, it doesn't matter. Side, angle, side. So we're going to say yes for both of these. But I'm going to, again, put a star on here because, or actually 2 stars, maybe 3 stars. Because this one means that the sides have to be our same proportion. Sides are same proportion. There we go. And instead of proportion, you could say scale. That's another way of thinking about it. Angle, angle, side. That's also good for both of these in a similar way because we have 2 angles. Side, side, angle. This is good if right triangle. And for the and that means that it's actually hypotenuse leg is what we call it. And it's the same thing here. So we're going to say that for this other side. If it's hypotenuse leg, then it's good enough. Okay, so now let's see what this even means and how we would put these things together. So for this first one, it says angle, angle. It says at least 2 angles are equal. So right here, we're going to say that R is equal to itself because it's an overlap shared angle. We're also going to say another angle is equal. So we can either choose RGH, RST, STR, GHR. So let's choose RGH. And RGH matches this one up here, S. And because parallel lines and that angle is in the same position, we call that corresponding angles from parallel lines. So now we need to say which triangles are equal to each other, or proportional to each other. So RGH, I need to pick the same triangle that's kind of in the same position. RST. RST. All right, now let's look at this one. This one's interesting because at first you look at it, it's like, nah, one's upside down compared to the other. Well, it's still got two matching angles. We could say that angle M matches the other 63, which is angle C. And angle L is going to match the other 43, which is angle B. And because it's just given in the picture, it's just marked with the measure. But if we say that now, look at this, says LMN, LMN. So I go from 43 to 63 to empty. I have to follow that same pattern, the corresponding pieces. That would be B, C, D, 43, 63, empty. So this should be B, C, D. All right, now we have a couple of angles that look similar, and let's see how they match up. So we have D matches L. So angle D matches angle L because it's given in the picture. It's just marked. They're both 65 degrees. But now we have these angles in the middle here, which is interesting. So LEK or KEL and DEC or CED. So we'll say the CED and the KEL, that those match each other. The reason why, when two angles are across each other, kind of in a scissor shape, that's vertical angles. That's the vocabulary word that we say there. Okay, now let's see how this works. I'm going C, D, E. So I'm going from the empty corner far away, 65, and then the middle. So I got to go empty corner, 65, middle. That means it's going to be KLE. KLE. Awesome. And now we're going to say that we have side angle side, two pairs of corresponding sides are proportional, and the angle between them is equal. All right, so what does that mean? What we have to say is that the angles are equal to each other. So MLN, this angle here in the middle, is equal to QLR, the other angle across from it, because of vertical angles. Awesome. And now it says proportional side lengths. We got to choose which pieces kind of match each other. I noticed that there's a short side and a long side, and then I have a short side and a long side. So I got to match short with short and long with long. So the short and short, I'll do 18 over 27, and that's going to be equal to 22 over 33. Now, how might I check this? Okay, I'm going to go to math.new, and the fraction that I had was 18 over 27 equals 22 over 33. And what I'm doing right now is I'm just double checking, making sure that both of these sides are in fact the same scale. That has a scale of 2/3, that has a scale of 2/3. What that means is that this smaller one is 2/3 the size of the bigger one. And my scale ratio, you could say, is 2/3. Now, if you just looked at it the other way and said, well, I want to do the big one to the small one, and you said 3/2, that's fine. And you could have written these fractions the other way around with big over small instead of small over big. Both ways show the same relationship. Now we have LMN equals, so LMN, so I'm going from middle down the short side and then finishing at the final corner. So I'm going to start at the middle down the short side, so L, Q, and then finish at R. So L, Q, R is how that would match. All right, we just have a few more here, not too many. Let's see if we can finish them up. Side angle side again. So we have an angle marked congruent in between, and that angle is here and there. And now we want to see 12 and 36. 12 over 36, well, that's kind of convenient, it's exactly the same, 12 over 36, 12 over 36. And if I were to put that in here again, 12 over 36 equals 12 over 36. It is pretty obvious that those should be equal to each other. If I needed to figure out the reduced fraction or simplified version that's equivalent of the scale ratio, either one of these answers would have worked, 12 over 36 or 1 over third or anything equivalent, but that gives me my scale ratio of 1/3. I also need to choose which angles are equal. Looks like we have angle V is equal to angle G because of those congruent markings. And it's because it's given in a picture. That's really common to see. All right, this one is not similar. We have vertical angles, but let's take a look at how these pieces work together. I have a short and a long side and a short and a long side. So I'm going to do the shorts together and the longs together and see what happens. If I have 8 over 39 equals, and what was the other pair? So the short over short is 8 over 39. 12 over 55. 12 over 55. Okay, now when I try to rewrite these, they don't reduce at all. So they can't reduce to the same thing. But let's double check just to make sure by doing a decimal approximation. So I'm going to double tap. And it says that side's about 0.205. And the other side is close, but they're not equal. So if I were to kind of rewrite this or think about it, I would say those are not equal. So those can't be the same. So 8 over 39 does not equal 12 over 55. Therefore, they are not similar. They would have had to have been equally the same. One side not growing different than the other. Okay, now for side, 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 it's very similar to the other ones. The difference is that all sides are proportional. So we got to match the small with the small, medium with the medium, large with the large. So let's say I did small, medium, large from the first triangle. And then the larger triangle, now I'm going to say the small is 49. And the medium is 56. And the large is 84. And if you were to simplify each of these fractions, you would get a scale of 1 to 7, because they're all, like if I divided this one by 7 on top and bottom, I would get 1 over 7. Divide this one by 8 and 8, I'd get 1 over 7. 12 and 12, 1 over 7. All right, let's do another one. I got to match these together. So if I go 7, 8, 12, G, E, F, it says E, F, G. So I'm going to be between the 7 and 8. So between the medium, I'm going to go across the medium side for E, F. And then F, G is going to be the long side. So I want to do medium, then long. So I'm going to go Q, R, S. Q, R, S, because I go across the medium, then across the long side. All right, here's our last one as we finish up here. Proportional sides. So we got small, medium, and large. Let's do the small numbers first. So I got 50, 55, and 60. And I want to show that that is equal to 70 is the small side, 77, and 84. And again, if you put these into your calculator to simplify those fractions, you would figure out that they all are equal to the scale 5/7. Now let's match up the pieces here. UVW is going to be equal to going across the long side, then the medium. So long and then medium. So that would be CD for long, and then E to finish for the medium. So C, D, E. There we go. And that's all of these notes. Just